Hello, I'm Patty Simpson with Simpson Math. Let's look at the vocabulary that surrounds confidence intervals. So some of these vocabulary words we're going to be using over and over again as we talk about confidence intervals. First, let's look at inferential statistics. We've moved into inferential statistics. All inferential statistics is that we're going to make inferences or educated guesses about populations using data drawn from a sample of the population. So we're going to pull a sample and get some statistic and use that to help us make an inference about the entire population. And that's what makes it inferential statistics. So one of the things we're going to do is we're going to pull that statistic or a point estimate. A point estimate is a single value given as an estimate of a parameter of a population. So in other words, again, we pull that sample, we find a statistic. We're going to call that statistic that we're going to use to infer about the whole population a point estimate. So that's what a point estimator is. An unbiased estimate is a point estimate that accurately represents the population. Remember that a bias, statistical bias, just tells us how close a statistic is to that parameter. Bias in statistic is just how close is it to the actual parameter. So we want an unbiased estimator, which means that we want it to be the same as our parameter. And we saw with the central limit theorem that the mean of a sampling distribution is an unbiased estimator because the mean of that sampling distribution is the same as the mean of our population. We saw that when we did the central limit theorem. So an unbiased estimate is just is going to give us a good representation of that parameter. An interval estimate is a range of values within the value of a parameter has a stated probability of occurring, within which the value of a parameter has a stated probability of occurring. It's an interval, and we're going to say it has some probability that the parameter is inside that interval. So like I did in a previous video about the birthdays, where I said your birthday is in this range. That's what an interval estimate is. I'm going to estimate that interval, that range of where I think that parameter is. A confidence level is the probability that the value of a parameter falls within a specified range of values. How confident am I that that parameter is within that interval estimate? That confidence level is really just that probability. How probable is it that the parameter is in there? Now, when we put these two together, when we take the confidence level and we take the interval estimate and we put it together, we call that the confidence interval. So it's just, this confidence interval is just a range of values with a specified probability. It's those two things together. A margin of error, which maybe you've heard in polls, they talk about a margin of error, is the largest distance from the point estimate that a confidence interval will cover. We'll talk more about the margin of error in a later video, but this margin of error is just the standard deviation times however many standard deviations out you want to go. That's what it is. But it's the largest possible distance from a point estimate that a confidence interval covers. Then the critical number equals the number of standard deviations that contain the percentage of statistics. Critical number equals the number of standard deviations that contains the percentage of statistics in the relevant sampling distribution. The critical number is just the number of standard deviations out we're going to go. That's what that critical number is. So it's got this fancy name, critical number, but it's really just the number of standard deviations we're going to go out for our confidence interval. So here are some of the vocabulary words that we're going to use throughout as we talk about confidence intervals. Let me just give you a small visual to go along with these. So I'm going to show you on a normal distribution and a confidence interval and what these different words are. So we know that a sampling distribution, we know that the mean of a sampling distribution is an unbiased estimator. It's going to be the same as the parameter. And then we know that that sampling distribution has a nice normal shape. So I'm going to show my standard deviations here and draw myself a normal curve like the sampling distribution would be. So here's a nice normal curve with those standard deviations. And that mean then is that, that unbiased estimator. Or if we find a proportion, we saw that the proportion is also an unbiased estimator. Now, the interval estimate is just the range for where I say the parameter is going to be. I'm going to claim that the parameter is somewhere in this range or somewhere in that range. That's my interval estimate. And then the probability that goes along with that is my confidence level. So you know, within here, the probability it falls in there is 68% by the empirical rule. The probability it falls in this interval estimate is 95% by the empirical rule. Now when I put those together and I say with a 95% confidence level, the parameter is going to fall within this range. That's a confidence interval. It's got to have that confidence level and then also the interval, the range that we have. Then the margin of error, well, let's say that I have a 95% confidence level. The margin of error really is just this amount. Whatever that distance is your margin of error. I know 95% is out 2 standard deviations. So we're going to learn later that the margin of error is just your standard deviation times that critical number of how many standard deviations you're out. So that distance right here is your margin of error. And then the critical number tells me out how many standard deviations. Well, for 95%, my critical number then would be 2 because I'm going out 2 standard deviations. So there's some vocabulary that we're going to use as we continue to talk about confidence intervals. Math Made Simple is Simpson Math. Thanks for watching.